In this video, you will face with one of the most beautiful phenomena in electronics, POV displays. This is a POV display, also called a fan display. You can display simple text, dynamic text, or even images on these displays. In this video, I'm gonna make this project using pure microcontroller, not Arduino, and I will teach you many practical points in the heart of this project. This project is not as difficult as you expect. You just need to know basics and some detail, that's all. In this video, I will explain PCB and schematic in detail, and I will show you how to make it by yourself. And also, I will give you files and codes needed to build this project. Please stay with me until the end of this video. Let me start from these PCBs. I have already designed the schematic and PCB in Altium Designer, and for fabricating I have sent the files to PCBWay.com. Look here, this is the PCB they provide. Very nice, sharp and well made. A big thanks to PCBWay.com for sponsoring this video and fabricating such an admirable PCB in really short period of time and with a reasonable price. More about them later in this video. So now let's get started with the build. This is my old POV display and this is new one. In this video we are going to see how I made this new POV display. To assemble components to PCB, I need to fix the PCB somewhere so that I can solder components easily. These board holders are good choice for fixing the PCB. The components used in this project are very small SMD components, so I'm gonna use 0.3 mm soldering wire. This is the PCB we are going to assemble. Very nice, sharp and well-made two-layer PCB. Firstly, I need to hook up the PCB to the board holder. After that, I have to solder components one by one. I prefer to start with SMD LEDs. These are red SMD LEDs. I'm gonna look close to one of them. Like every other LEDs, these LEDs have two terminals and also they have polarity. If you look at its back, you will probably find one of these signs on the back of the LED, which is indicating the polarity of its terminals. Let's consider the T-shaped mark. The terminal above the T-shaped mark is anode and the terminal below the T-shaped mark is cathode. If you look for these signs on the back of the LED and you can't find any of them, you will probably need to refer to datasheet to find right polarity or carefully test the LED using 2.2K resistor and a 5-volt power supply to see in which polarity the LED turns on. The LEDs are here and they are connected to port D of microcontroller and each of them is in series with a resistor. I mean these LEDs here this is the place in which the LEDs are gonna soldered. These LEDs are so sensitive to heat, I have to solder them quickly. I usually start with putting a little bit solder on one pad without the LED and then put the LED on the pad using tweezers, then solder one terminal of each LED to soldered pad quickly to prevent possible damages. Look here, this is the result. Next step is to adjust LEDs to fit them right in their place. To do this, I put my finger on the LED and melt the solder with my iron, and in the same time I fit the LED with my finger. Be careful about hot iron to prevent injuries and skin burns. Now it's okay, LEDs are fitted nicely on their place and it is time to solder other terminals of LEDs. This is so easy. In the next move, I'm gonna solder resistors for LEDs. I mean these resistors. These are 560 ohm resistors for restricting current flowing to each LED. On the PCB, they are placed on bottom layer here. They are placed here. In 3D view, you can see them here. These are resistors for restricting current flowing to each LED. In the same way as LEDs, I solder one pin for each resistor pad and then solder resistor to pad using tweezers and hot soldering iron. Even though these resistors are not much sensitive to heat, I have to be careful about them. Look here, this is the result. Some of resistors need to be adjusted. I'm gonna adjust them in the same way as I already adjusted the LEDs, and finally I solder the other terminal of each resistor. It seems perfect. Before going to next component, I need to test the circuit to make sure the LEDs were not damaged during the soldering process. To do this, I'm gonna apply 0 volt to this pin, which is ground for the circuit, and then apply 5 volt to microcontroller pads, which are going to provide on-off signals for LEDs. I mean these pads here, 1, 2, 3, 4, 5, 6, 7, 8, which are these points on diagram. The test is done, and now I'm confident that the LEDs and resistors are healthy. The next component is an IC, LM324 op-amp IC. Let's look at the diagram and see what this IC is doing. Here it is, IC LM324. It have 8 inputs and 4 outputs. Each output have a number, OUT1, OUT2, OUT3 and OUT4, which is indicating the corresponding op-amp number. Each output is related to 2 inputs. For instance, OUT1 is related to positive in 1 and negative in 1. If the voltage on positive in 1 is more than negative in 1, then output become active. I mean voltage on OUT1 become equal to VCC, which in this project is 5 volt. And if the voltage on negative in 1 is bigger than positive in 1, then output become inactive and voltage on OUT1 becomes 0 volt. Here, positive in 1 and negative in 1 are valued through this sensor and this potentiometer, which I will describe them in detail later in this video. Now I'm gonna solder the IC to the PCB. Pay attention to IC direction. There is a mark on PCB and also on the IC, and I have to be careful to put the IC on the PCB correctly. Firstly, I need to solder one of side pads before placing the IC on the board, and then solder the IC to that pad using tweezers and hot soldering iron. It looks perfect. Now I need to solder other pad on opposite side of the IC to fix the IC on its place, then I can solder other pads easily. For example, if I solder pin 1, then it is better to solder pin 8 before other pins. Next component is microcontroller. Here I'm using ATmega8. Process of soldering of the MCU is similar to LM324 IC. This is the microcontroller. The microcontroller is going to signal LEDs on right time to create visual illusion of displayed text. Here the microcontroller is on top layer here. If you look attentively, you can find a circular mark on both microcontroller and the PCB, which help us to find right direction on soldering the MCU on PCB. To properly soldering the IC on PCB, I need to first solder a pad and then place the IC using tweezers on its place in right direction and solder its pin to a corresponding pad on PCB. This stage is so important. If you solder first pin unadjusted, all other pins will be soldered unadjusted. I can adjust the IC a bit to fit it on its place. One pin on the MCU is soldered on a pad on PCB. Other pins are free and I can adjust the IC easily with my finger. Now it looks good. Let me solder other pins. There are shorts on MCU pins which can be fixed easily using desoldering wick, but I think we faced a bigger problem. Let me see if the solder wick can solve the problem. This is a solder wick, also known as desoldering wick, which is used to remove extra solder from pads and pins. This is the bigger problem I already said. The IC is not well placed on the PCB. This is my fault and I'm sorry about that. Let me handle this. I just turned on my hot air soldering station. I'm gonna use my hot air to remove the IC and repeat the process. Okay, now the IC is removed and I can solder the IC again. Before that, I have to clean the MCU pads on the PCB using solder wick and tissue. Then I have to wait for the PCB to cool down. You know, I am not much patient, so I will cool the PCB down using freeze spray. That's enough. I'm gonna repeat the process. Here I have soldered one pin and I'm checking IC placement. It's okay. Next I need to solder other pin in opposite side of the MCU to fix it on the PCB. For example, if I soldered this pin first, it is better to solder this one before rest of pins. Now is the time for assembling a green LED here to indicate if magnetic field exists or not. I have used this LED to calibrate the sensor using this potentiometer to find out whether the op-amp IC and magnet sensor works or not. Actually, this LED will turn on when a magnet is near the sensor somewhere here. I forgot to say that we need a magnet sensor in this project to set a start point for the display. This is a magnet sensor. This magnet sensor have 3 pins: VCC, ground and signal. If you apply 5 volt to VCC, 0 volt to ground, then the sensor will show magnetic field by voltage value on its output pin. If I bring a magnet near the sensor, voltage on output pin will change. This sensor is placed on the PCB here. So when the PCB is rotating, the sensor will pass in front of magnet and voltage on output pin will change. On the other hand, we have a potentiometer here which is providing reference voltage. This op-amp compare voltage and provide a digital output which is input to microcontroller determining when the sensor is passing the magnet. You may ask what will happen if there is no magnet sensor, or why using magnet sensor in a POV display is so important. Look here, this is a POV display which is using magnet sensor to determine display start point, and this is the same project without magnet sensor. If you ignore to use the magnet sensor in a POV display project, the displayed image will rotate uncontrolled like this. Let's go back to the green LED. Like any other LED, I have to solder one of pads and then solder the LED on the PCB using hot iron and tweezers. Of course, this LED needs a resistor to restrict current flowing to it. Here you see two resistors, a 10K resistor to restrict green LED current and a 5.6K resistor for pulling up reset pin on microcontroller. I soldered these two resistors as usual. Next component is a 10K SMD potentiometer which should be soldered here. It is used to provide reference voltage to compare with Hall sensor analog output. Just like any other component, I solder one pad on PCB and then stick the component to that pad to fix it on the PCB, then I can solder other pins to pads with ease. It seems okay. Next component, which is so important, is capacitor. There are several capacitors on the PCB which are used as decoupling and filtering purposes. For example, this capacitor here, these two here, this one, and some others on bottom layer here, this one, and this one. I'm gonna solder them according to PCB and the schematic here. Since precise timing is required in this project, using external crystal is unavoidable. Here I am using 8 MHz external crystal to provide high accurate timing in microcontroller. Next component is the Hall sensor or magnet field sensor. It is necessary to detect display start point. I had a mistake when I designed the PCB. I replaced ground and signal pins while designing the PCB by mistake. But no problem, I will compensate my mistake during soldering the sensor. Next step is to solder two pin headers here and use a jumper on it as on-off switch. After that, I need a tiny battery to connect here for powering the circuit up. But don't forget to charge the battery before use. If you don't know how to safely charge a lithium battery, I have a video about charging rechargeable batteries. There is a link to that video in description. When the battery is charging, I will do other things. Here we need to hook up the PCB to a DC motor. So I will use this plastic propeller. First I have to heat it up using a lighter so I can reshape it and cut it easily. Then it is ready to be stuck to the PCB using hot glue. Now it is ready and the battery is charged a little bit, which is enough for testing the circuit. I'm gonna solder the battery to the PCB, but before that I will test the circuit using portable power supply to find out if there is a short on the circuit or not. If there is a short in the circuit, the ampermeter on the power supply should display a high current. Be careful about polarity of the voltage. A wrong polarity can waste all of your efforts in a fraction of a second. After testing the circuit, it is safe to connect the battery. If you don't do this test and there is a short in your circuit, you will never realize the problem until the circuit starts to make smoke. Look here, the ampermeter on portable power supply shows 0 amp, which means that there is no short in the circuit and it is safe to solder the battery to the PCB. Now it is ready to be stuck on the PCB using hot glue. In this stage, I'm gonna adjust the potentiometer to calibrate the sensor to magnetic field. That's okay, and we are ready for last step. Last step is to upload hex file to the microcontroller using programmer. In the previous video, I have told you in order to flash AVR chips, you need to connect these pins on the programmer to corresponding pins on the microcontroller. Here we need to consider connectors on the PCB to make us able to connect programmer to the microcontroller. Here in this project, I have considered such connectors on the PCB. These are 5 through-hole pads on the PCB connected to MISO, MOSI, SD card, reset and ground on the microcontroller, and I just need to connect programmer corresponding pins to that pins using jumper wires. Then it is ready to flash the chip. After writing codes and flashing chip, it is ready. When the PCB is rotating, I put a magnet near the PCB to set a start point. This is the little cute toy I made. If you want to make it by yourself, you can simply download and use a schematic PCB and code files from the link in description. If you intend to make one of these, you need to fabricate PCB. I ordered this PCB on PCBWay.com. They are fast and they offer reasonable price and produce high quality PCBs. PCBWay provides many other services such as 3D printing, CNC machining, PCB and PCBA. Placing order on PCBWay.com is super simple. You need to sign into your account and simply add a PCB prototype order. Then you will see a form to determine what exactly you need. After filling the form, click on Calculate to display approximate price. After that, you can upload PCB files to your order. It is recommended to upload Gerber files for more accurate fabrication. After adding files, you need to wait for PCBWay to calculate exact price for your order. It will take several minutes. Last move is to pay your invoice and wait for PCB to arrive. That's simple. Make sure to check out their services. There is a link to PCBWay.com in description. So my friends, I hope you enjoyed this video and learned something new. Thanks for watching. If you enjoyed this video, please hit the thumbs up button and subscribe to my channel. See you in the next video.